You're now plugged into the Delphi podcast.
Hey everyone, it's Tommy and welcome back to the podcast. Today I'm blown away and just really excited to host Andrej, who's the co-founder of Grass or getgrass.io. It's a really viral crypto AI project built on Solana. They have over 2 million users scraping the internet's data, eventually going to segment that, validate it, authenticate it, and use that in AI for training and everything else. Andrej, how's it going?
Hey, it's going well, man. And thank you so much for having me on here.
I'm excited to have you, and it's just the memeability of the grass thesis is crazy. I feel like every time I open Twitter, I see like this cute little grass guy with some meme around grass.
Yeah. We actually, my co-founders and I spent the entirety of a few days trying to think of the perfect name for this protocol. And when we landed on Grass, like we immediately just fell in love with it. I remember like it got brought up at the table, and we said, okay, that's the one. For so many reasons, and the memeability was like a big part of it. We were thinking, what's a good name for a protocol that needs virality to really work and really take off and like provide maximum value, and that was the one. Beyond that too, like we really like some of the metaphors that come from it. I think yeah, sorry, go on.
No, it's just great. I mean, like the grass is always greener, watering the grass. Like it's such a like AI is so complex, and to have something so easily shareable is just the dream.
Totally. Yeah. I guess like while we're on that topic, one of the Easter eggs behind the name grass is like the technical name for like a part of the grass, like of a piece of grass in biology is actually called a node. It's
Oh
like
wow.
the stem of a grass leaf. Yeah. So I remember when we found that out, we thought, oh, this is pretty awesome because our users are effectively installing grass nodes. So yeah, that worked pretty perfectly.
Oh wow, yeah. The stem of the grass is punctuated by nodes. A node is a place where the leaf attaches to a stem. Oh wow, that actually that's a great Easter egg.
Yeah.
So Andrej, in your own words, give us the elevator pitch for what grass is.
Yeah, definitely. So the concept itself is actually pretty simple. We looked at the AI category as a whole, and there's a lot of focus right now on solving a very big problem, which is this necessity for massive amounts of compute to build highly performant AI models. And what we realized was that when you're scaling the amount of compute in a model, you're obviously doing that because you're adding parameters to it, or in other words, you're adding tokens or like words, right, that are going in as input data. And as the need for better and better models and like even more specialized models grows, we realize that quality data is actually very scarce. It's a lot scarcer than people think. And the vast majority of it is just sitting on the internet and being gate kept by a very small number of institutions. So when we set out to build this, like there were a few inequalities that we were aiming to solve. And like, one of them was the very obvious, hey, there's only a few companies that are controlling a lot of web data that is being contributed by, their users on their platform. And we don't find this fair, A, for, the users, and B, for any smaller company that's trying to compete with them. But separately, there's a huge inequality in the way that a lot of this data was being gathered. Now, like what a lot of people don't realize is when you're scraping web data, you can't really make millions of web requests from an AWS instance. You kind of have to distribute that load through hundreds of thousands or even millions of devices around the world. And more often than not, those devices need to be run on residential networks. The reason for that being a lot of web servers just go ahead and block data center IP addresses, or like if they see the device fingerprint of a big server, they'll just automatically block it. And what a lot of companies were doing, in the last few years has been installing SDKs on people's devices without their knowledge in order to effectively hijack their residential networks and use that as a proxy to scrape all this web data for their own benefit and not compensate end users. So Grass is really a network of 2 million devices now that are scraping the web in real time and creating very, very large data sets and also cleaning them in the process. And the idea, behind scraping tons of web data as a starting point made a lot of sense to us. because after you've sourced a lot of data, there's a lot of things that you can do with it. You can label it, you can embed it, you can do all kinds of things. And for us, it didn't make sense for all of that to live in separate protocols or separate projects, because at the end of the day, you want to accrue as much of this missing value back to the users, like back where it belongs. So yeah, that's basically what Grass is.
I love your analogy on how hard it is to traditionally scrape the internet, right? My fiance asked me to download Rakuten the other day, and my first thought after all of our diligence calls with you guys was, are they installing a secret scraper on my computer or something random, right? I have no idea if they do, but it's just wild. I mean, one question that, just to like close the loop here is that I think when people think of data scraping, they think, hey, a centralized company could easily do this from a data center, right? Like this is not hard. Historically, it's not going to be hard on a go forward. Like, what is the counter to that? Is the counter just that they're not able to? Is it that they get blocked? Like, what is it?
Yeah, I mean, a centralized company can do it, and centralized companies are doing it, but they're taking advantage of millions of networks around the world without really paying the people that are hosting those networks. And we just think that's very unfair. And at the end of the day, it's not a scalable solution. So, like, to give you a quick example, if you go to like the top smart TVs right now, the most popular screensaver apps were actually developed by web scraping companies. And because most smart TVs these days stay turned on in the background, running all kinds of processes, it was very easy for them to sneak this type of software into those, because you turn on a screensaver, it's just always on in the background. But what your TV is effectively doing is using a little bit of CPU and a bunch of your bandwidth to go and scrape public websites. So it is possible to do this as a centralized company, but it's near impossible to do it fairly, and to not just compensate users, but also give them the benefit of having some ownership of the network. And that's one of those things that, when we first set out to build this, it took us close to no time at all to realize this is something that is enabled by crypto, and there's no other way to do it.
So just to double click on that, I mean, I think it's wild that we have TV screensavers, scraping the internet and us not knowing. Like it's just, it's wild what these plugins and apps get away with without our knowledge. But, if I'm a centralized company just trying to scrape the internet on a go forward, like not just the historical data, but like the data on a day by day basis that's just, continually and exponentially growing. Am I able to do that from a centralized data center today, or do I need Grass?
You would need Grass, because as more and more companies are realizing how valuable the data that they put on the internet is, and more of them are starting to take the necessary measures to block other companies from scraping their web data. So they're gatekeeping it effectively, even though it's public web data, even though they're scraping each other and all their competitors. They want to hoard their own web data and make it only accessible to residential devices. Now, if you're trying to scrape the entirety of a very big website from a data center, you will notice that you're either very quickly rate limited, or worse, you get honeypotted. And that's been a really cool phenomenon, or I wouldn't say cool, it's a very interesting phenomenon that we're noticing, where web servers are beginning to honeypot web scrapers. So if they detect a crawler or a scraper, they'll purposely start inserting links for the crawler to click on that either lead to nowhere or feed them with fake news. And this is a type of data poisoning that if you don't use a solution like Grass, you have no way to really get around it.
It's crazy. So the data poisoning item, I think you shared when we met in Denver, like really blew my mind. So I guess like a basic example of that would be if you're a centralized data center scouring the internet and you're looking at flights from here to Dubai, right? Or something, for token 2049, like they'll just feed you like 2x or 3x prices. So the users go directly to like their website. Like, is that a basic example?
Yeah, definitely. A lot of websites will tailor what they show you based on your browser fingerprint and your IP address.
That's crazy.
Yeah. And, this has been going on in e-commerce for many years, because companies like Walmart recognize the fact that Target was scraping them on a daily basis in order to price their products competitively with them. So if they detect an IP address that was in a data center, they would just show them the most expensive product as a default, or even just give them a fake price. These things sound very innocent as at first, where it's like, okay, it makes a lot of sense. But when you throw AI into the equation, it creates an avenue for a lot of potential problems. So, like to give you a quick example, back when ChatGPT, like when GPT-4 just added its live browsing feature, I went to go and try it out, and it was around Black Friday, and I thought, okay, I'm gonna ask GPT, where can I get the best deal on a certain pair of running shoes, like in this city? And I asked it that question, and it went and did its job. It browsed the web, and it gave back 5 or 6 different links. And I remember thinking, wow, this is a really cool feature. And then I clicked on the link that had the cheapest price given by ChatGPT, and the price was completely different when I opened it on my local device. And that was kind of eye opening because you you know that website that was selling this pair of running shoes recognized like, hey, there's an AWS server that's accessing our website. We don't want to give it a real price. We'll give it a much higher price. And it gave a price that was like 2 times higher. And, sure, you can kind of fix this by going and like visiting that site yourself and fact checking it. But imagine a world where websites that are showing language data purposely change what they're showing you when they detect an AI model browsing them. That can be kind of scary, especially with the things like the election coming up. There's so much incentive to do this, to feed false knowledge to AI models at the web server level. And when these models start responding to humans with fake knowledge, they're a lot more convincing than something like, let's say, a search engine, which might give you like the wrong link, because in a lot of cases, like, and in a lot of ways, like these models are capable of passing the Turing test. And yeah, so that's one of those things that it's one of those things that we're on a mission to solve as part of Grass's infrastructure.
Yeah, I mean, it also gets a little crazy when you think about pulling data for AI applications that are not just the text prompting that we all know and love, right? Like it's not just in, you went to ChatGPT or Gemini to get your sneaker price or what have you, but what about when we have full-fledged AI apps pulling data, right? Those will be way more, I think, maybe widespread and have more issues.
Absolutely, yeah. And it would be really silly for anyone to say that there's going to be any large company in the next decade that is not going to be using LLMs, that is not going to be using these types of features to query data from the internet and create actionable insights from it. So it is a real problem, even outside of language, like you said. I mean, like there's already, like travel is a great example that you gave earlier. There are already all kinds of chatbots that are using LLMs to interface people, help them book flights and things like that. You can already imagine like how much value could be destroyed for end customers if these types of models are being honeypotted.
Yeah, no, I'm with you. I want to get into how Grass sort of enables us and double click, but since we're on sort of the implication side, I'd love to talk through the interplay of Grass and AI a bit, right? So we've been sort of talking about, pulling real-time data or relevant data, but maybe I'd love to get your take on like first principles, how Grass interacts with AI models, right? Is this data used for training large models? Is it used for training narrow models? Is the data used specifically to pull in new and relevant information that's necessary to completing a request? Right. We'd love to sort of dive into that side of it.
Absolutely. Yeah. So we effectively, the vision for Grass is to exist at every single one of those layers. Our vision really is to build an internet scale web index and to scrape absolutely everything that's publicly available on the internet, archive it, and make it readily accessible to anyone trying to develop any type of AI model. So you can kind of think of it as this data layer, like a huge repository of either historical or recent data, that any AI developer can go in, take bits and pieces of it, and build any specialized model that they want. Beyond that, too, we eventually also want to enable inference through the Grass network, and that's something that we've just been discussing, which is when you put a prompt through through a data center IP address to go and like when you're accessing the internet and like adding context from using some scraped data in real time, you're a lot better off doing that through a network like Grass because you're eliminating any sort of IP based biases, for example. So yeah, both at the real time level, but then also as a mass repository for anyone to build any type of model from. So either whether it's a base model that uses up like almost all of it, or for fine tuning, where someone will say, want to build a model that specializes in teaching people how to code, and they want the entirety of Stack Exchange to help them fine tune that.
So Andre, I think double clicking on the example of a developer app would be really cool to dive into, right? And you sort of mentioned that having access to like highly specific data is good for building specific models. Let's just double click on that example, right? Like I'm a developer, I want to build a very specific AI model to help me, be a developer, right? What sort of data would I need to build that, and how would I use Grass for that?
Absolutely. So I can see Grass fitting into three levels there. The first one is the very obvious scrape data from forums and blog posts where experts in certain fields are helping each other develop certain types of applications, or just even helping them with coding problems in various languages. The second one is actually inference. A lot of API docs get updated very frequently, and new ones pop up on a regular basis. So it would be very difficult to continuously fine tune a model every time new API docs come out, or every time a website updates, some features of of some function, or some API. So you do need a certain element of real-time inference there. And then the third one is actually annotation. Before you put this model into production, you probably want a lot of humans to go and actually annotate these responses and label them as right or wrong. So for instance, like if you're writing a model, or if you're building a model that can go and help someone write an application, you're going to want many human hours of just checking the outputs, marking the responses, and then creating some level of reinforcement learning. And all three of these things are things that Grass does. And the way it would look like for this developer is they'd go and access the repository and fine tune their model based on all these blogs and forums and anything else that's coding related, for instance. And then they'd go and plug into Grass's data labeling feature, which is coming out soon, and get a bunch of people who have, based on a certain trust mechanism that we're working on, shown that they're actually quite good at detecting issues with code, or like solving certain coding problems. And then it'll give them millions of, or not millions, but like thousands of example prompts and responses to go and mark. So they're effectively acting as teachers who are grading assignments. And then you go back and create this reinforcement learning loop. Then once this model's in production, you plug it in directly into the Grass network to go and just, if someone goes and asks to use a certain API, it'll quickly go and scrape that company's website and check, okay, this API got updated. We're going to have to change some of these features. So Grass would fit into like all three of those levels there.
That's so cool. Yeah. And, one thing I think that's worth you sharing with the audience, and we'll get into why having a deep in AI network is so cool in solving this issue. But one thing I think that's worth hitting on is the value or the performance of a specific AI model versus a general one, right? So, like at an abstract level, like a specific developer AI or LLM, whatever you want to call them, would be way better than using something like a Gemini, because you don't have to reason about the entire world, right? You can be very specific. But I would love your take on like how much better the experience is using a narrow AI model versus something broad.
Yeah, I think one of the analogies that I really like is, like everyone, I think most people listening, like in middle school, probably had a moment in a science class or something like that, where they had to go and mark a bunch of dots in a plot and then draw a line of best fit. Now, the way AI models work is actually kind of similar to that. It's called it's obviously not as simple as linear regression, but at the end of the day, you're training something, and then every run of the training process is evaluating a certain amount of error and taking certain steps to minimize that error until it creates like this best fit that's possible. Now, if you're building a generalized model, you want it to be reasonably good at many things, and that ends up being very computationally expensive, and it ends up being reasonably good at everything but not very good at very specific applications. And in order to get a model to be very good in a very specific application, like you're going to have to fine tune it with some relevant data that pertains to that application. And in many cases, this does not need as many parameters as some of these huge models. Like GPT-4 was what, 1 trillion parameters? I think that got leaked. You don't need 1 trillion parameters to build chatbots to do very specific functions. And I mean, that being said, there probably isn't even enough data to justify that many parameters for a lot of these more specialized applications. And like when you have a smaller model that's fine tuned on very high quality, very specific data, it's like you can think of it as that, back to that line of best fit example. When you have a bunch of dots like on a scatter plot, and you're trying to draw the line of best fit, it's a lot easier to draw the most accurate line when there's less dots on that plot. And at the end of the day, what you end up with is a smaller model that is better at the task that you actually want it to do. And I think one thing that, you know, is getting a decent amount of attention, but it's going to become a bit more of, I guess, a narrative in the space, is the fact that, like, I guess like the end goal is to be able to chain models together to perform certain tasks, right? Like you want your AI assistant to go and do like many different things and base its decisions on the next task on the output of the previous one. And you end up in a place where like 1 or 2% of error can propagate very quickly as you chain these models together. And you want to really focus on accuracy on very specific tasks, because each of those different tasks, if you have like any amount of error in any of those tasks, then you increase the probability of just the next task being the completely wrong thing, or even like the wrong model being called. So I think in the narrative of AI agents and having models that are chained together, you benefit very highly from smaller, more specialized models that have been trained on very high quality data on a smaller number of parameters.
Andre, I love that thought flow, right? It sort of it just reminds me of like the many chain versus monolithic chain debates in crypto, and sort of what we've been through there. I mean, I think that makes sense, right? Like, I think a thesis of, potentially millions of highly specific AI models makes a lot of sense, right? But I think one of the things that's interesting for Grass is like, it doesn't, I don't think it really matters to you guys, right? Like, if there is a world of millions of highly specific models trained from these specific data tranches, or sort of one big model trained from all your data, like, I think it's sort of a win-win for you guys, right?
I would say so. Yeah, the protocol's success, I would say, is pretty agnostic to which direction the world goes in. But I'd say that everything that we know today is pointing towards a world of very many models. And I'd be absolutely shocked if, when we eventually reach AGI, it'll be a single model. I think it'll be a lot of very small models that work together. And this might have just been a rumor that I saw on Twitter. So maybe if someone's listening to this, like reference this fact, but I saw some rumors that some of the more recent, like very high performant models actually have several models under the hood that are working together. So
that just makes so much sense. Yeah. It really does. And Andre, just, one final thing just to close the loop on, I would love to double click on before we go to the deep inside. It's just, I love your mental model on how this data goes into the models, right? Like, my rough mental model is that, data changes these zeros and ones or parameters within the model, and then that's sort of set in stone. And then the model itself can sort of come back to the Grass network if it needs a timely price or like real time information. So it's sort of like, it seems to me like two different swim lanes for the Grass network. Would that be fair?
Yep, that's a very good way to characterize it.
I think switching gears to the deep inside, Grass has had like insane success in attracting sort of supply side users to the network, right? You guys have 2 million Chrome extension downloads of people like supporting the network itself, right? And actually doing like credible work here. How have you been able to amass that many users, right? It's such a large number for crypto.
Absolutely. Yeah, I mean, we ourselves, if someone told us 10 months ago when we first launched that we'd be at 2 million downloads now, we'd probably be surprised as well. We've been really thrilled with the level of engagement and the excitement from our community. I think it really boils down to a few things that are actually quite simple, but that we spent a lot of time focusing on. The UI is incredible. Like, the UI UX is incredibly simple. All you have to do is quickly download something and make an account. And we tried to minimize the number of clicks. And throughout the process, and like I have to give a lot of credit to our CTO, Chris, because he spent many hours focusing on this. We wanted to make this feel as much like a Web 2 app as possible. There's no reason that people should be punished for using a Web 3 product. So that was like a big part of our mentality going into all of this was a lot more Web 2 apps have gone viral and mainstream than Web 3 apps. So clearly they're doing something that many Web 3 apps are ignoring. And that something is the simplicity and the focus on UX. So we made it very, very simple to add your device as a node on the network. And beyond that, we referral gated it. And one thing that a lot of people don't know is that actually we've spent $0 on advertising. We've never paid any influencers. We've never paid, things like marketing agencies to come in and start shilling our product. Because to us, the mission for this protocol is so compelling that we felt that as long as it's explained and conveyed properly, people will feel incentivized enough to go and join it themselves. We didn't need to go through any like crazy tactics to get there. And we also spent a lot of time focusing on making sure that our referral mechanism incentivizes the right type of behavior. So as a lot of people know, like right now, people are earning points for uptime as we bootstrap the network. And if you refer someone, you get 20% of the points for uptime that they're earning. And when you combine all these things, like the fact that it's very easy to install, the fact that it doesn't feel like a Web3 app, so you can go and refer people that are non-Web3. There's zero cost to onboarding. You don't have to go and buy a device and hook it up somewhere. And the fact that it's very easy to refer people, it's like 2 clicks. We started seeing tremendous growth. And a lot of people with, very large followings were inherently, they saw the benefit of just referring as much of their following as possible. Like we're incredibly grateful for that. But I think permeating all of that too was this messaging that we spent a lot of time on, and that we still spend time on it. We're trying to blow the lid off of a kind of crazy industry where people are just being robbed. And like, I'm not talking just a few million people, I'm talking hundreds of millions of people around the world that have been kind of sitting in silence and just accepting that this is the reality of the internet that we live in, where I'm going to go and install something, and in order to enjoy a product, I am going to be robbed effectively. Like I'm paying for this internet bill, I'm paying for this compute, and like some other companies will go and rob me, and all I get in exchange is the ability to use this application for free. Like we just felt that wasn't fair. And I think like one thing that our community does a really, really good job of explaining to people as they onboard them and join us is like, hey, look, the world as it is isn't fair. And we have a choice here. And if you're on the right side of that choice, you might as well just join Grass and like join the movement. So I'd say it's like a combination of all those factors really that led to the level of adoption that we're at today.
Yeah, I mean, I know a lot of thought went in from you and your fellow co-founders on it, but it's sort of like, I sort of view it as like just checks a lot of boxes quick for a large target market, right? Like it doesn't take a lot of mental load or capacity or strain to just think like easy Chrome extension, sort of deep in AI and sort of augmenting the internet, right? And obviously throw in some cute memes there. Like that's obviously surface level for what you're doing, but I think just all those things together makes it really approachable, and definitely, hopefully, something other founders could try and approach too.
Yeah, I appreciate that.
Is there a difference when people download the extension? Like if they're on a laptop or if they're on a phone or something, like is there a difference in like the quality of data they're scraping or anything along the lines of what they're performing?
That's a pretty good question. Early mobile devices tend to do a bit better with web scraping. The reason being the way IP addresses work is they're actually in limited supply. When the internet was designed, it was designed with this IP addressing protocol called IPv4. And it put a pretty small cap on the total number of IP addresses that are even possible to exist on the internet. And because of that, when someone connects to the internet from a mobile device, and there's more devices now than IP addresses. So like a lot of cellular networks have a ton of phones that are sharing the same IPv4 address. And if a website's being scraped and it wants to rate limit a mobile device, for instance, it makes it kind of difficult to do at the IPv4 level, because it would be blocking an entire cell tower, and an entire region of a city wouldn't be able to access that website. And that's obviously something that they don't want to do. In addition to that, it's usually highly unlikely that a mobile device is being used to scrape the internet. Often when websites see that device fingerprint, like they'll show less captchas, for example, because they feel a bit more certainty that it's a human. That being said, though, I know a lot of our users have found really creative ways of downloading the extension on Android phones. But the only mobile application that we've actually released to date is on the Saga app. So if you have a Saga phone and you are one of the 1/5 of Saga users that hasn't downloaded Grass, I'd highly recommend giving it a try.
So 80% of Saga phone users have?
Yep, something like that.
That's crazy. And I think a key question for me is just on, how does the extension or app sort of know what to scrape, right? Like who's kind of giving it the instructions of, go scrape that Walmart website, or go scrape this form that a developer needs to train a highly specific AI model. Like how does that how does that orchestration and instruction sort of happen?
Absolutely. So at the kind of in the background, you've got this validator that is saying, hey, we need to go and crawl the entirety of this domain, or we want to go and scrape this specific data from this website. It'll go and send all that information to a router. And then based on the domain, the router actually is able to determine, okay, we want to scrape this domain out of this region because it gives us either the lowest latency or the right type of data in the right language or the right numbers or whatever it is that they might need based on like IP addresses. And the router is constantly communicating with all of the Grass nodes, and it knows which ones are online, where they're geolocated, and what the IP address is. So it's able to go and route those requests through those nodes. Now, in terms of what's being scraped, at the moment, we're working with some fairly large open source AI foundations, and they're expressing their needs to us, and we're tailoring the scraping towards that. But as we progressively decentralize the protocol, I really love the idea of our community going in and voting on, hey, like we're building this internet scale web crawler effectively, and we're going to capture all of human knowledge that's been put on the internet and turn that into a structured database that anyone can go and access to build AI. And as a community, we're going to vote on which domains are important to include in that set. To me, that's a very powerful concept, because right now there are 3 companies in the world that are actually able to go and crawl the entire internet and back it up on huge servers. The concept of just replicating this, but having it owned by the people who are hosting these devices or participating in the community, to me, and I think to a lot of people, is just a very, very powerful concept.
I'm with you. And another thing that the maybe more of the crypto native folks care about, because as you mentioned early on, the zillions of TVs that are running screensavers that are scraping the internet, people just don't even care about, right? But I think people in crypto and hopefully beyond will care about the privacy of downloading an extension, right? They might worry that hey, is Andrej looking at what's on my computer right now, or looking at my websites? Like what sort of privacy guarantees do people have?
Absolutely, yeah. So the extension actually can't see anything that is on a person's local device, and it can't access any user's browsing sessions. And this is pretty verifiable. You can go and inspect it yourself. As we develop, other distribution channels such as desktop downloadables, or even one day we might do hardware as well, right? Or even the phone app. We're going to go through the right third-party auditors and third-party firms, all the antiviruses and everything else that's everything we can possibly do to prove this, right? Because at the end of the day, we actually don't care about what people are doing on their personal devices. There are countless companies out there that are doing that. That's not what Grass is really focused on. Grass is focused on public web data. So all it really cares about is using a bit of bandwidth on someone's computer, a little bit of CPU. So just a few resources, but nothing to do with anyone's personal data. And yeah, like right now it's verifiable, and eventually, we do plan on open sourcing many different parts of this as well for anyone to go and check this if they want to.
No, that's awesome. I mean, the verifiability is nice. I don't know how the hell I would ever audit a TV screensaver. I'm sure there's people that figure out a way to do that. So I guess just, maybe a longer term question for you, but like obviously the supply side is sort of a lock, I think, at this stage. But the part two we've been discussing, right? Like taking this data and making AI models and things like that, and using Grass Network for real time info, like that's still, a bit of a ways out, right? I think. How are you thinking about like that process, right? Like delivering on that side. Like, is that a go to market question? Is it like a biz dev question? Like, how does that reach the next stage?
Yeah. So there are a few factors at play. We're we're pretty lucky actually that our protocol is pretty well positioned for the current data supply shortage that exists, especially among like AI developers. It feels like every other day, large companies are signing like exclusive deals with large platforms in order to use their data for AI training. Like you can see Reddit did that with Google. Actually, Google's done that with a few folks, including Stack Exchange. And we've been thinking a lot about this and how, effectively with a network like Grass, you can go and replicate that exact same data set, um, and make it more accessible to any company that's trying to go and do this and do the same thing and wants to go and compete with these tech giants. And we do think that's like, a very important aspect here. And it's not very difficult actually to go to AI companies and sell them this type of data. Like there's no question around its like demand. There are probably some questions around price discovery because for the most part, a lot of language data was almost valueless up until like 2 years ago. But I'd say that isn't actually the big issue to focus on there. I think the big issue to focus on is the fact that these tech giants, through their centralization of power, um, are not just signing exclusivity deals with other tech giants to use this data, but the data itself actually belonged to a lot of contributors in the first place. Or I'd say like was contributed by a lot of users on their platforms. So I'd say, when a company like Reddit goes and says, "Hey, we're selling our data to these AI companies," in our opinion and the opinion of many folks, like they're just a platform. Like they're selling their users' contributions, and the users are not seeing the other side of that. And before we even get there, because in like technically it would be very easy for us to go and just replicate that deal and do it many times over. Like before we ever get there, like we want to make sure that the users of those platforms are also being compensated. So not just the Grass nodes that are doing the work of kind of liberating that data from the clutches of these tech giants, but then also making sure that the people that are contributing that data in the first place get their fair share. So there are a few factors at play there, but I'd say that's probably like the biggest thing that we're.
No, I like the flow, and it is. I mean, maybe it's more of a niche sort of market, but I'm sure there are people out there that just have really cool sets of data, or maybe like by proxy have an application or somehow to get really specific data that they just they don't have a place to put it on the internet, right? And maybe Grass could be that way that they do that.
Yeah, definitely. I actually think more and more companies are going to start realizing that their proprietary data is quite valuable, especially for AI models that are being trained to do very specific tasks. And more specifically, actually, as AI moves beyond the realms of just software and like we start using it in robots, there's going to be a lot of companies out there that just have vast amounts of proprietary data that can be used to go and help train these robots, for example.
Yeah,
And what's that?
I mean, one question for you, like, is it like, I'm glad you brought that up. Like, companies that have specific data is valuable. Is there like, does it have to be like this fully clean, data set that they upload, or could it just be like years and years and years of like customer support logs? Like, does it matter?
In practice, I'd say it doesn't really matter what they're providing because data can always be cleaned. I mean, it adds a little bit of work for the developer, but at the end of the day, what really matters is the semantic information within that data. So, as an example, like for us, like what we deal with is actually very dirty data. at first, right? When you're scraping a website, if you're like crawling the entirety of it, you're including a lot of HTML and a bunch of other nonsense that you're actually not really that interested in. And what you want to do is strip all of that away to a point where you have the structured data set with just the words and sentences that you actually care about with the information that you need. Then only then do you go and like vectorize that data and then plug it into a model. But at the end of the day, like what Grass is being supplied with, like very fundamentally, is a lot of dirty data that it then goes and cleans up. And I actually think it's going to matter less and less how data is structured in the first place, as long as the necessary information is in it, because LLMs are just getting better and better of doing the data cleaning themselves, which is kind of a cool concept, right? Where you can have a pretty small model, like trained on like not as many parameters as like some like as GPT-4, for instance, like just like some smaller model that's been fine-tuned to just clean and extract very specific types of data from like a really dirty data set. So I don't think that burden is really going to fall on any of the companies that want to go and monetize that data, at least, especially not long term.
Using an AI model to clean data is super cool. I recommend we call that spring cleaning for the grass network, but we'll leave that for you guys. Andrej, one more set of questions for you is just around you guys decided to build on Solana, right? And there are other crypto AI projects that have also made that decision, right? Like IONET for distributed GPUs and clustering. Disclosure, that's a portfolio company of ours as well. But curious why you decided to build on Solana, and if there are other infrastructure plans you're thinking of here.
Absolutely. So Solana just made a lot of sense to us for a number of reasons. I mean, beyond the very obvious, like very strong community and very strong deepened presence that already exists on Solana, the most important aspect of the chain for us was the technical one. And ever since we started Grass, like we've always approached every problem as pragmatically as we possibly could. And we looked at the landscape of L1s and L2s that was out there, and we kind of evaluated all of them as fairly as we could. And we said, okay, well, Solana is the fastest chain. It's the cheapest chain, and it's the chain that's actually innovating faster than any of the others. So there's a very high likelihood that it's going to maintain that advantage over the next 5 to 10 years, because at the end of the day, we have a very long-term mindset when building something. And it ended up being kind of a no-brainer after we've just looked at all the options. That being said, though, I think blockchain technology as a whole has a long way to go with scaling. And, we were looking at Grass and saying, okay, we want to make sure that this protocol is as fair as possible. We want to create lineages between scraping actions and data sets. And that involves recording and verifying literally every part of that scraping action. And in some early tests, when our user count was actually about a quarter of what it is today, we realized that if we wanted to do that, we'd be hitting like 1 million transactions per second. And that would do nothing but absolutely congest Solana. And it was very obvious for us to like say, okay, well, we can't go and do that, but we do want to verify all these web requests because we want to make sure that we have maximum transparency for our users. We have data provenance. Then we also have we can also make sure that our users are actually being compensated fairly, because you can look at every scraping action as granularly as possible. So then we said, all right, well, what if we were to strip away all the digital asset parts of the blockchain and then keep everything that relates to validation, and then just build that as a scaling solution on top of Solana, where anything relating to digital assets and all the summary statistics get posted to Solana as a base chain. And then everything else that we're validating exists as an L2 on top of Solana.
That's so cool. Yeah, I mean, definitely a logical choice. And glad that you're surrounded by other projects you could potentially work with there as well. Andrej, so a bit of a random question for you, but I think it's kind of important. The transparency of this entire flow, like the impact of Grass, I think isn't totally understood in its gravity, right? Like if we have full AGI, if we have billions of users interacting with AI applications all on a foundational model that was trained on data that we don't know, we can't track, we can't audit, we don't know the biases. Like that is a bit of a scary world, right? If you use Grass to train these models and they become huge and performant and useful, how easy will it be to sort of back into where that data came from, how to authenticate it? Like, is it a block explorer? Do I ask somebody? Like, I think that's kind of important over the next 5 or 10 years.
Absolutely. Yeah. Yeah. And to answer your question, like it would be a block explorer. We can click in and see the proofs of, or basically like hashes of the proofs of all the data that was scraped and the scraping actions and the nodes that have done it. More importantly, though, the data sets that will be provided by Grass will be augmented with these proofs. And what I mean by that is when you look at a Grass data set, you'll be able to see, okay, this line of this data set relates to this scraping action that happened on this day that ran through this node. And I think for a lot of folks, it isn't immediately obvious why this is important. And I think that's because it's still a fairly nascent industry. But we believe that AI is going to inevitably follow in the footsteps of search engines. It's almost predetermined. Like if you think about, what an LLM chatbot does effectively, it does a very similar thing to what Google does for a lot of people, or what like Bing does. Like when people are searching the internet through a search engine, they're asking a question or they're querying for some information, and it's and it's using its huge index to go and like give them the most relevant links or the most relevant information that pertains to that question. And chatbots are used in a very similar way. And for many years, people have kind of been poisoning these search engine results by uh, throwing a bunch of information on their websites to like optimize for SEO and like to make sure they're on the front page. And many times it's very immediately obvious that like, hey, okay, this link that popped up at the top, I searched for a certain product and their competitor showed up first. Like they clearly optimized their SEO game to make sure that they show up every time I search for their competitor. You can kind of quickly look past that. Like there's all kinds of like little things with that. Certain news outlets are doing the same thing to each other. And like I wouldn't say it's completely innocent, but it's like a kind of a necessary evil for how search engines get monetized, and we all sort of deal with it, and we're able to kind of look beyond it, and it doesn't impact us too much that directly. But when you're looking at LLMs, and if you think about it in a particular way, it actually gets kind of scary. If you think about all the data that an LLM got trained on, and how persuasive an LLM can potentially be, especially as they get better and better and better. It doesn't take that much to alter a data set in order to influence like the response of an LLM. And we already know like there's unlimited incentive for advertisers or political parties or even criminals in some cases to go to data providers and tell them, hey, look, I would like to insert 5,000 instances of this fact so that when a model gets trained on this data set, it picks up all that knowledge that might be incorrect, and then introduces like a 1 or 2% bias to the model. Now, when you think about a model that reaches mass adoption that was trained on that data set that got poisoned by some third party, a 1 or 2 bias can be a really scary thing, right? If you have like 100 million users of some chatbot LLM, like just thinking about the law of large numbers, there are millions of people that are being affected, and like who will be persuaded to act in a different way because they received a certain piece of information from this LLM. And if a world exists where Grass achieves its mission, this will be completely avoidable. Because if someone wants to go and
that's powerful.
Absolutely, right? And
yeah, that's huge. And a lot of people have pushed back in conversations, and they're sometimes on this topic, and they say, oh, it's so hard to figure out the bias. I'm like, I don't know. I mean, you could kind of just look at the results of your responses, right? But sometimes the biases will be so subtle and so smart, right? Like if you're in a dating app and you're not seeing a specific class of people, right? Or something like that, like that's a scary world.
Oh, definitely. And if you think about it, it's kind of like I was actually thinking about this on a walk the other day, how like I was trying to like create a mental model of how many discoveries and how many advances in like human civilization were caused by search engines. And it was kind of interesting to think like, okay, in the last 20 years or so, anytime someone wants to go and start researching a certain topic, like they'll start with a search engine, right? And then they'll work their way through like other sources, but like that's usually the starting point. And it's pretty crazy to imagine like how many discoveries and like breakthroughs were actually enabled by this technology that otherwise wouldn't have happened or would have been delayed by many years. And but then technology is always this double-edged sword, right? Where anytime you have a huge advanced technology, like for example, the printing press, it enabled democracy effectively, right? Because it allowed people to go and like spread information like wildfire and make decisions as a huge group, no matter how big the country was. But at the same time, that technology was used by dictators to spread propaganda and like influence people and like absolutely destroy lives and countries, right? Now, search engines, it ends up being a lot more subtle, but this type of you can, by introducing certain types of bias like in certain countries, like it ends up being kind of the same thing. This tool that can be used for good, for like creating scientific breakthroughs or like learning new things, can also be used maliciously by third parties to influence human decision at like a very large scale, and that only gets amplified with LLMs.
Yeah, it is a really, I mean, it is a really scary world, right? And I also don't exactly know, like, I'm just so used to the internet, and as we all are, and all the applications that we use, that I'm not sure what the internet would look like if we pulled back the curtain a bit, right? And we didn't have all the interplay with companies and blocking and all these things. Like, I'm a little scared, but also sort, obviously kind of interested.
Yeah, yeah. I mean, that's kind of what we're trying to do at the end of the day, is just sort of pull back a layer, and say, hey, look what's going on under here. Like, there's a lot of parts of the internet that are kind of starting to rot, but at the same time, we want to present people with a solution, right? It's
Yeah.
like,
No, I'm with you. I listened to a podcast yesterday, and I forgot who the host was. I'll link it in the show notes because it was good. But oh, sorry, it was Inside China's AI Ecosystem, and it was from the Cognitive Revolution. And I was pretty shocked at how far behind China is, because they don't have like an open AI or anything like that, right? They don't have like those research groups. But I mean, in a world of equality, it seems like Grass's protocol could be used by any country that wants to make AI, right? I mean, you're not really selecting.
yeah, I definitely say so. I mean, what we want to make sure, and even beyond just use cases too, we want to make sure that the data is as unbiased as possible. Like, there's a huge, like, if you look at most of the image data sets, for example, or a lot of the large language corpuses that are being used to like train base models, so many of them have an English bias and B, a Western bias. And beyond that too, like when you're doing data labeling, a lot of labeling ends up happening in like hyper localized regions where a lot of people have the same political views and things like that. Then you end up having like the Gemini situation, right? What we want to make sure we do is like accurately or like fairly represent every region in the world, because there's no reason why AI shouldn't exist for every culture and for every language and for every belief. It just
Andre, just to double click there. So like data collection from a certain region, let's say Japan is one thing, but if that data is then labeled in a different region and then fed back into that, Japanese AI model, you could lose a ton of context, is what you're saying.
yeah, absolutely. Yeah, you definitely could.
Yeah, that's a pretty big problem, because like even if you have gold like god tier data, if you're mislabeling it, it's useless or less useful.
Yeah, it's true. And I'd say that's a big reason why many countries are not really as far ahead as like the English speaking countries when it comes to AI development, is just the availability of quality data that's been collected, right? Like most of the AI companies right now, they use Common Crawl as a base case, and most of Common Crawl is just in English. So if you're, there's like countries with like massive populations out there that just like were, sure, people speak English, but it's not the language or like the bias that they want to introduce in their model. They end up having to look for other solutions. So like there's a huge, I'd say it's a green field right now, pardon the pun, in terms of providing the right type of data for these types of clients or customers.
Yeah, no, I'm with you. I have a pretty like okay understanding of how AI works with like the English language, but once you start to go into like like the Chinese language, where like every character is like multi-token, like it gets just so confusing to me. I don't, but another podcast episode, I guess.
Yeah, definitely. It's also a topic I don't know much about, to be completely
Yeah,
honest.
yeah.
Chinese token. Yeah, yeah.
No, it's a tough one. But Andre, in closing, I mean, from when you started until today, I'm sure your views on crypto AI and AI in general have, probably shifted or evolved, even outside of Grass itself. I'm curious, like, how has your views changed since starting Grass, right? And not Grass specifically, but just in AI. Like, is it scarier? Is it moving faster? Are you blown away? How have your views changed?
I've certainly been blown away. I mean, we started working on Grass probably a month or two before ChatGPT came out, and I remember at the time we were telling people around us, "Hey, look, there's going to be a world in which web scraping is going to transcend just e-commerce companies trying to scrape each other's prices, or like travel companies trying to get the best price, or whatever it might be. There's going to be this whole world of data science, but we thought that was maybe 5 to 10 years out. We had no idea it was 2 months out. That was mind blowing for us. And then, it wasn't a huge surprise to see the centralization of power, and like, I guess just like fundamentally makes a lot of sense that something that's very expensive, both computationally and monetarily, can only be done by like a small number of companies. But, like, I guess before all this began happening, I sort of saw crypto as fairly limited in its use cases outside of democratizing things like finance. I thought it was pretty cool. Like, there were a lot of really cool experiments out there. I mean, like, Helium's an amazing project, and like, with what they're doing, but it was kind of difficult to see a lot of use cases for the democratization of certain workflows, for instance. And when AI came out, it kind of blew the lid off of all that and said, look, there's this entire new paradigm in technology, and it's on a collision course with crypto. And where exactly it fits in many different aspects is still to be determined, but in others, it's actually quite obvious. So, yeah, I'd say, like, over the last couple of years, like, we've gained a bit more certainty around how crypto is going to fit into all of this, but there's still a lot more to find out. And I'd say, if anything, I've gotten more and more optimistic on like some of the more quote unquote real world use cases for the technology.
Yeah, no, it's exciting. And Andre, I just want to thank you so much for taking the time to come on the podcast. The Grass story is awesome from start to finish, and in its simplicity for the user, but also like its broader impact for crypto AI. We're thrilled to be investors to back you and your team, and I'm really excited to do this again. So yeah, just a huge thanks for coming on, and I can't wait to share this.
Thank you so much. I appreciate it.